One of the studies that impressed me, and people have asked me why over 27 years you've got these 20 peer-reviewed studies that have been published in medical journals and scientific journals on ribosine. Why weren't they human studies? And I asked that question of Dr. Nagasawa, and the answer he gave me was wonderful. He said, number one, you can't control the variables in a human study. You can't control the air the person breathes. You can't control what they eat. You can't control their sleep patterns. There's so many variables that can affect glutathione activity that you can't control. Whereas with the animal studies, you could put them all in the same environment. They all breathe the same air. They all eat the same diet. They all do the same amount of exercise. The only thing that changes is either they get ribosine or they don't. When they tested how it raised glutathione levels in the various tissues, and in heart cells, in 16 hours, ribosine raised the glutathione levels by 80%. And as you mentioned, the heart needs glutathione. I mean, it never stops. 24/7.
Well, there's more mitochondria in the heart muscle than any other cells in the body.
Yeah.
So it needs that glutathione more than any other cell.
And then the liver uses it for detoxification, and a liver cell has more glutathione than any other cell in the body, I've heard. And yet even in the liver cells, it increased glutathione levels by 50%. In the muscle cells, think how we use our muscles, it increased glutathione levels by 150%. In 16 hours.
And that's why it's so good for athletes. When they optimize their glutathione levels, they're going to generally perform better.
And recover better.
And recover better, sure.
More quickly. And